Ready to rock and roll? All right, good stuff. Welcome back. Come on in, have a seat, get seated. Take your time, but hurry up. But take your time. All right, my friends, we have even less time than before. This time we have absolutely no time to waste. So, as always, I encourage you to take notes of these slides. This slide is the most important one. It contains my coordinates. It also contains the code that you're going to need to be able to follow along at your own leisure later on. So get to this, get a photo of this slide. Of all the slides to take a photo of, this is the best. Again, you can find me on Twitter. I'm happy to answer questions that way. You can find me on email, if you need to. It's a thing. I work on the Spring team. My name is Josh Long. It's so nice to meet you all. Videos, book, podcast, blog, screencast, book, new book, Reactive Spring. And that book is something that you can buy right now. It's an early edition. It's not done yet, right? So I'm still working on it. You buy it now, you get the final edition when it's done. And in the meantime, if you find something you don't like, we can change it, right? We can fix it. It's an open kind of thing. Okay, good stuff, my friends. Come on in, have a seat. So this book is really, it's the big picture of what we're going to talk about is reactive programming. And the book covers that, but we're also going to have some time to cover that today together here and now. And so we're going to talk about reactive programming in the Spring ecosystem. Now, reactive programming is not a particularly new idea. It's been around for a long time, right? It's been around for a fairly good long time, and it's a fairly well understood idea, a fairly well understood answer to a problem that has existed for an even longer time. That problem, that very simple problem is, how do I handle more users? How do I scale to handle more users? How do I handle more capacity in my services, in my application? Oh, people are coming in. Good stuff. Come on in, my friends. So the question is, how do I handle more users in my service? How do I handle better scale? How do I accommodate more requests? And it's not hard to imagine why we need to do this, right? It's not hard to think about the reasons that motivate this new demand, right? Think about what's happened in the last 12 years, right? We've had the introduction of the iPhone. We had the introduction of Android. We saw iPads and smart TVs and Rokus and Xboxes and PlayStations and cars. Everything has an SDK. So everything acts as a client to all these different services. This creates more demand on your services. The other thing we've seen is that we've moved away from the traditional sort of server-side generated view to this more client-service architecture. And this client-service architecture means that one user interface might require 10 network calls to get your data. Now, this isn't such a big deal if your network calls are quick, if they're fast. Because what happens in a traditional approach to getting responses from a call, from a network service? In a traditional web server, what happens? You've got a server socket parked on port 8080. It's listening for incoming requests. As the requests come in, that server socket says, okay, I'm going to create a thread. And that thread is going to handle the incoming request. And inside that thread, what do? Well, you call other web services. You call your JDBC database. You send messages out to message queues. You do whatever you need to do. And as you're doing this, in that thread, what are you doing? You're using types that are based on Java I/O input stream and Java I/O output stream. So what happens when you use input stream? When you make a request to another service to get data, what happens? You're sitting there, you're making requests to the service, and you're waiting for the bytes to come. Where's my data? I'm just waiting for those bytes to arrive. And you're sitting on that thread. And this is the problem, my friends. You see, waiting is not a problem. The fact that we have to use a thread to do that, that's the problem. It's not cheap to create threads on the JVM yet. In a few years, maybe, hopefully, fingers crossed, it'll get a little bit better. That's one problem. So we're waiting for threads. We're waiting for data, and that requires us to use a thread. And so the problem is we can't create infinite threads, right? It's not cheap to create threads on the JVM. Each thread takes about 1 megabyte of context. That megabyte is associated with bookkeeping that the JVM does for the thread. That bookkeeping is stuff that you have to do just for every single thread because each thread is backed by an operating system thread. That operating system thread is what actually has which actually does the work for us. So when you create 1,000 threads, you get an extra gig of RAM, right? Just to create threads that aren't doing anything. Could you create 1,000 threads, though? Could you do anything useful with 1,000 threads? Probably not, right? Because you don't actually have true concurrency if you have 1,000 threads, do you? You don't have true concurrency beyond the number of cores in your machine. Everything after that is just an illusion. Even if you have 1,000 threads, all you're doing is moving work on and off the CPU as quick as possible to create the illusion that you're doing work concurrently. But actually, you're not. And even worse, because you have more threads than you have cores, you have dispatching, you have context switching. You start some work here, pause it, move over there, pause it, move back over here. You're constantly moving back and forth from one core to another. This context switching means that even though you were trying to make your program faster, you ended up making it actually a little bit slower, right? Not only have you not gained any, you've lost RAM, you've lost performance, and now you're actually slower. You're handling transactions slower. And this is because we're using a very simple API. We're using Java threads. And we're saying, this thread is mine. I own this whole thread. I don't have to share it with anybody. I am the only thing on this operating system that has any importance, right? It's a very greedy attitude. If you don't share with other things in the system, you get into trouble. And it's not your fault. You're using Java thread. Java's threads don't really give you a nice API to say, hey, somebody else can use this, right? They don't give you a nice callback that you can say, I'm done with this. There's no way for the runtime to look at what you're doing and say, hey, this thing is waiting for something. We can reuse that thread. We can take that thread from it and do some work on it until this asynchronous thing that we're waiting for comes back. So this is a problem. The other problem is that once we have the data, can we be certain, 100% certain, that the data will come all the time? Can we be certain that it'll come infinitely quick, that it'll always be fast? Can we be certain that the network will always be infinitely fast and that there will be no latency? Of course not, right? Can you assume that the services to which you're making requests will always be available? Of course not, right? So we have this interaction model that assumes the happy path. We're making a network request, and we're waiting for bytes to arrive. As the bytes arrive, we hope the next byte will arrive. And hopefully, it'll be super quick. But what if the next byte doesn't arrive? Do we just wait? We're doing .read. We're doing input stream.read, and we're waiting for these bytes to arrive. There's no way to push back. There's no way to say, oh, this isn't going to work. I want to cancel. Okay? So we have several problems here in the traditional approach to building systems. First of all, threads are expensive, and the traditional approach requires that we use threads. Second of all, the programming model is not one of message passing. It's one of input streams and output streams. And this doesn't lend itself to building robust distributed systems. So we need some way to sort of get around those limitations. What we need is some way to model data, to describe streams of data that are asynchronous. Remember, the world is asynchronous. It's truly asynchronous. It's not synchronous. So we need a computational metaphor, a data type that we can use to describe this true asynchronicity. In the JDK, it's fairly straightforward to say I have an asynchronous single value. We use a future or a completable future. But how do you say I have an asynchronous, and multiple values? We didn't have a very good fix for this for a long time. There were no good options for this for a very long time. And so a lot of different organizations got together. Pivotal, Netflix, Lightbend, the Eclipse Foundation, all of us got together, and we defined a very simple sort of set of common ground interfaces. These are called the Reactive Stream specification. And they extract out the 4 basic types that are required to describe or to model asynchronous streams of data. The Reactive Stream specification is so useful. They're very boring. They're very simple. Okay, to be clear, they're very simple, and we're going to talk about that in a second. But they are so useful, and they're so obviously what is required that they have since been incorporated into Java 9, which is now 2 years older, more than 2 years old. So they're in Java 9. They're part of the JDK for 4 different versions, right? but they are pretty boring. They are pretty plain. They don't give you support for working with these streams of data. Think of the reactive streams types as being kind of like Java arrays. Java arrays they're a way to store and to deal with sequential, contiguous streams of data or sets of data. But we don't have a way of dealing with asynchronous, discontiguous streams of data. The reactive streams types gives us that, but it still doesn't give us operators, things to work with those stream types. How do you do filter and flat map and all these kinds of things that we expect to do? Things that we can do with the Java 8 Streams API. These things are not available. And so different projects like Pivotal's Reactor fill this gap, okay? Reactor fills the gap. It provides operators on top of these basic types from the reactive stream specification. So you can use these technologies. You can use Reactor. You can use Arx Java 2.0. You can use Akka Streams. All of these different projects, for example, support these reactive stream types. They all support these they all support interoperability, and they all support operations on top of these different types. They give us a foundation on which to build streaming data processing platform or technologies, right? Are they enough? Are we done? Is that it? Can we go home yet? Of course not, right? Because even as good as all this is, it still doesn't actually get us into production, right? We have software that allows us to describe streams of data, but who cares if that doesn't allow us to build software for production, to solve data access, to solve web services, to solve security, to solve microservice requirements, right? All these use cases that we have to confront on a day-to-day basis when we ship software into production. Imagine, hypothetically, just as an example, hypothetically, imagine that the technologies that you and I are familiar with, the ones that we have used for more than a decade in some cases, imagine that these technologies, for whatever reason, again, just a hypothetical, okay, it's not real, but imagine it was kind of real. Imagine that these technologies, things like Hibernate, for whatever reason, for some reason we'll never know, imagine that whenever you tried to use Hibernate to map a one-to-many relationship using a Java util set or a Java util list. Imagine that whenever you tried to use these Java collection types, that for some reason, for whatever reason, Hibernate was really, really unhappy. Not just unhappy. Imagine that whenever you tried to use a Java util set or Java util list in your Hibernate mapping, Hibernate didn't just throw an exception. Imagine that whenever you tried to use a Java util collection in your Hibernate mapping, that Hibernate rendered an ASCII art middle finger and then kernel panicked your machine. Would you continue to use Hibernate if you knew that you could expect this kind of abuse? Of course not. Now, that's not to say that you're going to give up on using Hibernate. You're just going to give up on using Java util list, right? Hibernate is what you use to write data to your SQL data store in a synchronous and blocking way. It's the best there is at that. So I'm not saying that you should rewrite that. You shouldn't, and you can't. So there's no option, right? Use that. But if Hibernate says, oh, well, in order to support this, you must use this weird Hibernate set thing, then you're going to use that, right? It allows you to ship software into production. That's the goal here. The same problem confronts us with these reactive streams types. What good are they if nothing understands them? What good are they if the data tier, the security tier, the web tier don't understand them, right? So that's where the big first step for the Spring projects came in 2017 in September, so more than 2 years ago now. We released Spring Framework 5, which incorporates Reactor from the ground up. It builds a brand new web runtime from the bottom up into Spring Framework 5 itself, a reactive web runtime. On top of that, we have then released Spring Data K, Spring Security, Spring Boot, Spring Cloud, and so many other projects, all of which now integrate, wherever possible, reactive programming. So now, today, in 2019, as I stand here before you, you can build an end-to-end reactive system on top of all these components. And that, my friends, is what we're going to talk about. We're going to talk about the new stuff and the not-so-new stuff. And we're going to see how all these things fit together by writing some software, by going to my second favorite place on the internet after production. You know that I love production. I think about production all the time. I love production, and you should love production too. You should go as early and often as possible. Bring the kids. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and they cannot sleep, start.spring.io. And if you suffer from indigestion, a sour stomach, after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application, my friends. We're going to build a new application called the reservation-service. It's just going to be a service that talks to a database. And we're going to use a number of different databases here. But of course, we have the choice of, we have a couple of choices that we need to confront. The first choice that we have to make here is the choice of packaging. People get confused by this. They don't know when and where to choose which option. So let me do my best to explain. If by some terrible, terrible accident of time, space, you find that you have somehow been transported to the distant, distant, distant past, far, 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 far beyond modern help, then choose .war. But if you're here with me in 2019, then choose .jar. That's a big part of my overarching, guiding, personal philosophy of make jar, not war. And again, lots of options, lots of things that you could do, but I encourage you to accept the defaults. Now, the other choice we have to make is the choice of Java. And of course, I talked about this in my last segment, but it's worth reiterating here. Only 2 of these are correct. I'll give you a hint. This is not correct. So it's either this or this, right? It's the correct version technically. It's the most secure, most robust, fastest version of Java there is today. It's also the correct decision morally. You don't want to go home and have that discussion with your children that you're still using Java 8, okay? Don't do that. So we're going to select those. I'm going to bring in the reactive web support. I'm going to bring in Lombok. I'm going to bring in reactive MongoDB. I'm going to bring in R2BC. I'm going to bring in Postgres. And I think I'm going to bring in RSocket, okay? So there we go. Good stuff. So now I've got RSocket, reactive MongoDB, all that other good stuff. And we're going to hit generate. And that will give us a new project here. Okay? I'm going to open this up in my IDE. And it doesn't all that much matter what IDE you use, as I say always. I wonder if I can leave this bottle open and have that not end badly. All right, let's see. So reservation service. There's my brand new application. And what we're going to do is we're going to write data to the database. The first database that we're going to use is MongoDB. I've got that running on my local machine. So I'm going to comment out R2DBC. I'm going to comment out the JDBC Postgres driver. I don't need that. We can use Postgres R2BC, but we're going to come back to that in just a second. Okay, so comment this out. Okay, put that in here. Good stuff, all right, good stuff. So there's our basic application. And what I want to do is I want to write a simple application that persists data to the database. So I'll create a reservation object. It's going to be an entity that I'm going to persist into MongoDB. I'll create a field of type ID. I'm going to document. It's a document, right? So MongoDB, you have documents. You have collections. Collections are like tables. Each row or each record in a document is in a collection is called a document. So that's the essence of what I want to do. But of course, I need getters and setters and toString and all that stuff. So I'll use Lombok, right? There we go. There's all this. And that'll give me the essence of what I want to do. Now, what I want to do next is I want to create a repository to write this data to the database. So I'm going to create a reactive CRUD repository. This CRUD repository has methods that we will benefit from that will support the typical data management lifecycle. Things like saving, finding, counting, deleting, etc. And that should be very obvious. The things that are not obvious are these types. The first of which is a publisher. A publisher comes from the reactive stream specification. A publisher publishes, it broadcasts, it emits, it announces data to a subscriber. The subscriber, when it first subscribes to the publisher, is given a subscription. And we're going to come back to that in just a second, okay? This is very important, but we're going to come back to that in a second. As the publisher produces new data, each new record will arrive in the onNext method. When there are errors, if there are errors, they will arrive in the onError method. And this makes sense, because remember, stack traces are limited to one thread. So we don't want that to be we can't use try-catch, right? Because reactive code moves from one thread to another all the time. And then finally, when we're done processing the stream of data, the onComplete method will be called. So we have these very sort of obvious lifecycle callbacks. Let's talk about this. This subscription is arguably the most important part of the whole reactive streams, reactive discussion. When the subscriber wants more data, it can request more data by calling .request. It can say, I want 10 more records or 1,000 more records, and it'll get no more than 10 records. If it wants more records, it has to request another 10 or another 1,000 or whatever. The benefit of this is that the subscriber controls the rate of consumption. At no point is the consumer being overwhelmed by the data coming from the publisher. At no point is the service denial. It's not possible to denial of service that subscriber, because it controls the rate of production. It controls the rate of consumption. This is not a new idea. This is called flow control, right? Ever since there was one computer on the same internet as another, you've had to think about flow control. That's all we're doing here. We've got flow control. Reactive programming builds flow control into the top-level API. If you want to cancel the rate of production, you can do that as well. You can cancel the downstream producer. In the world of reactive programming, sometimes marketing takes the lead instead of technology, and so you might have heard the term back pressure. Back pressure means flow control. They're interchangeable. They're the same thing. Okay? So now, we have these reactive types. I mentioned that there are 4 interfaces in the reactive stream specification. The 4th one is called a processor, and it's just a bridge, a source, and a sink. If you understand these types, if you understand all 4 of those, then congratulations, you're already ready to go to Silicon Valley. You can raise $1 million and have crazy parties. You're already ahead of most people because you understand these basic ideas. Good stuff. But you can see they're very simple, right? They don't support operations. And so for this, we have a reactor. And like I said, reactor has 2 specialized types. The first of which is a mono. A mono comes from reactor. Not reactive streams, but reactor. It's a pivotal project. Reactor provides operators like flat map and filter and all that stuff. A mono produces no more than 1 value. So it's 0 or 1. It's like a completable feature, except that instead of being poll-based, it's push-based, and it also supports back pressure. Okay? We also have flux. A flux is a publisher that produces 0 or more values. 0, 1, 2, a trillion, infinite, etc. It can be as many as you want. It can be infinite. It can be 2. It can be whatever. Okay? So both of these are publishers. They both implement core publisher, which implements publisher, and there's the basic contract. But they have semantics. If you want to return a detail page, you return a mono of, let's say, a customer. If you want to return an overview page with a table, you return a flux of a customer, okay? So now we have these basic types. Now we can use that to write some data to the database. So that's what I'm going to do here. I'm going to say sample data initializer. Okay, I'm going to create a bean application ready event.class, public void ready, throws exception, and at component. So all I'm going to do is when Spring starts up, I'm going to tell Spring to inject a repository into this bean. I'm going to inject it into the constructor, and I'm just going to write some data to the database. So Josh, my name is Josh Madura. This is another Spring team member. Dave, right? There's Dave. Cornelia, good. Whoops. Okay, we've got Olga. We've got Spencer. We've got Ria. We've got, who else do we have? Stefan. 2. Okay. There we are. Good. So now we've got a bunch of names here. These are just names. Now, of course, this is a reactive stream of names. And I want to visit each one of these names and turn it into a new reservation. So passing a null. There we go. That turns into a stream of reservation objects. And I want to save each one of these to the database. So I could do this. I could say map.each1.reservationrepository.save, passing in this. And if I do that, I get back a stream of streams, don't I? A publisher of reservation. I don't want to do that. Instead, I want to unpack, I want to flatten the inner publishers. And I use flatmap to do that, okay? Flatmap means it takes this publisher that gets returned from save returns a mono. It's going to take that publisher and it's going to subscribe to the inner publisher. So I only get one publisher. I get a publisher of reservations. Now, if I run this code right now, nothing is going to happen. You see, this code is a cold stream. We've created a pipeline, we've connected the pipes together, and we've not turned on the water. So it's a cold stream. If we want to see the data, we need to subscribe, okay? That's how you make it a hot stream. But before I do that, let's clean this up a little bit. First of all, var, okay, 2019. Okay, there's this. I'm going to restart that. Good stuff. All right. Good. There's my pipeline. Now, what I want to do is I want to delete all the data in the program, in the database first. So I'll say delete all. And then, only after that is all finished, then I want to write the data to the database. And then I want to get the data out of the database, like so. And then finally, I want to write the results out. Okay? So I'm going to create a logger here using log4j on Lombok. And I'm just going to log the results out like that. It's a consumer, a Java 8 consumer. And now I can run this program. Let's see if that works, huh? Let's see if it works. Did it work? Look at that. There it is, my friends. There's the data. It worked. Of course it worked. It was a demo. What were you expecting? That was always going to work. That's not why we're here, my friends. What I wanted to talk to you about is this. This is the Spring Boot ASCII artwork. This artwork took a long time to get right. We on the Spring team have many people who are doctors, PhDs, people who in their previous lives worked in nuclear physics, star stuff. So it's for this reason that I want to take a brief moment, an ever so brief moment, to talk about what I consider to be a glaring and serious deficiency in the IntelliJ JetBrains product. Because even though I'm a fan, I consider this to be particularly short-sighted. Do you see this checkbox? This one right here? This one right here. Do you see that checkbox? That one right here? This one right here. This checkbox. Do you see that? This one right here? This one. Do you see it? That one? If you click it, don't click it. If you click that checkbox, it hides the ASCII artwork. Why? Why is that there? That's a dumb feature. Nobody even asked for this feature. So I did what all people would have done. I went on the internet and I cried. And so I was given a nice message of hope from my friend Jan Sebron. This is Jan Sebron right here. This is him, Jan Sebron. This is him. He's a developer advocate at JetBrains. And he shared with me this message of hope. This is Jan, right here. Boop. He sent me this message of hope, which I want to share with you here today. I've known Jan for a long time. I want to believe him when he says that this will be fixed. He works on the team. He knows what he's talking about. And I want to believe him. And, you know, whenever I ask him, he says, don't worry, Josh. The next release, it'll be fixed. Just relax, Josh. The next release will have the fix. It'll be fine, Josh. No problems, Josh. But you know what? I'm starting to think that maybe he's not telling me the truth. Whatever. I've got great database. I've got great ASCII artwork. I've got data in the database. I'm using MongoDB. It's worked just fine. We can go here to Mongo, and we can do db.reservation.find and get the data back. And there's all the data, right? So that's working okay. Now, what if I wanted to do this with a SQL data store? I'm using a NoSQL data store, MongoDB. We have support for reactively talking to Cassandra, Redis, MongoDB, and Couchbase, and Cosmos DB and Google Cloud Spanner, I think. But I know Cosmos DB, Azure Cosmos DB are all reactive. Oh, and Neo4j. Neo4j, the graph database. So we have a number of different NoSQL data store options. The question people often ask is, well, how do I do a SQL data store? And the problem has been that there has been no good API for that. And so we created one called R2DBC. R2DBC is a project that was designed to support reactive relational database connectivity, right? So this is it. It's a core SPI along with a number of different drivers, including Postgres, including Microsoft SQL Server, including H2, and so on. Okay. So we have R2DBC here. I'm going to comment out MongoDB here, and I've got a very simple domain for my application, very simple application. So I can actually just change a few things here. Et voila. I'm going to make a monotonically incrementing primary key, right? This is not a UUID anymore. It's a SQL data store, a SQL table. And basically everything else is the same. I'm going to write data to PostgreSQL, which I've got running in the background. Okay, so let's go here. Oops, I'm glad I fixed that. Postgres, and voila. Okay, pSQL, uorders. There we go. So now, go here, select all from reservation. There it is, delete from reservation. Reservation. So you can see the schema is a primary key, an auto-incrementing primary key, and a name column. Okay, so I'm going to run this code now. See what we get. It's saying that I don't have a valid URL specified. So I go to my property file. I say spring.r2dbc.url equals r2dbc Postgres localhost orders. Okay, just that. And I'm going to specify a username and password. This will be our little secret. Okay, you can't tell anybody, just us. Orders. Shh. Okay, so now there's our data. It's reactively talking to a SQL data store as well. So remember, these are natively reactive. These are built on top of asynchronous I/O. There's no blocking anywhere. We can't use JDBC for this. JDBC, unfortunately, is a blocking API. So this is a brand new initiative. We have a number of different organizations working on it, and there's a lot more coming down the pike. We've already got, like I said, we've already got 5 or 6 different SQL data stores already, and more coming. Now, I've got data. I've got data in the database. A very common question is, well, what about transaction management? How does that work in this brand new reactive world? Remember, things can move from one thread to another in the reactive world, right? And so the usual strategies that we have don't quite work. Imagine trying to do transaction demarcation in the traditional world. You have a thread local that stores your current transaction state. Well, what does that thread local mean when the pipeline can move from one thread to another to another to another? That thread local doesn't mean much at all anymore. So in Spring, in Reactor, I mean, we have this thing called a context. And so you can actually provide a context in your pipeline, right, like this. And it's just a dictionary. You can provide as many keys and values as you want, and we make sure that this context lives for the lifetime of the reactive stream. So it doesn't matter how many threads this code executes. Within the pipeline, I can ask my current context what the value of A equals, and it will always be equal to B, or whatever you want, right? This is how you can get around the lack of thread locals. This gives you the equivalent of thread locals, but it's much more intelligent and actually follows your pipeline from one thread to another. And we use this in a lot of different places in the Spring ecosystem. We use it to support distributed tracing. We use it to support automatic transaction demarcation. We use it to support security propagation. You know, you have a credential that's encoded in the current request, and you want to see what the current authenticated user is. So you can take advantage of it as well, but we can use it for transaction demarcation. It's actually very simple. So what I'm going to do is I'm going to create a R2DBC transaction manager. Right? This is the new reactive transaction manager API in Spring Framework 5.2. We're going to use the connection factory. CF, R2DBC transaction manager, CF, there we go. And of course, in order to be explicit, I can use @transactional if you want, but I like to use the transactional operator, which gives me explicit control. And then you can just use the reactive transaction manager. Okay, so transactional operator.create, transaction manager. There we go. So I've got that. Now I want to create a transactional service. So I'm going to create a reservation hyphen service. And we have implementations, by the way, of this transaction management support for R2DBC and for MongoDB and for Neo4j, right? So different databases are shipping reactive transaction manager implementations. So my service is very simple. It's going to take a number of different strings, and it's going to save them, but it's going to throw an exception if any of the strings starts with a lowercase. So I'm going to say start from an array, names. Okay, there's this. And then for each one of those, I'm going to take each name and turn it into a new reservation, just like we did in the beginning. And then for each one of those, I'm going to take it and save it to the database. And of course, in order to do that, I'll inject the repository. So private final reservation repository. Okay, and acquired args constructor. And I'm going to say this dot reservation repository at save r. Okay, there's this. Now, I've got to save that. Now, what I want to do is I want to make sure that for each one, I assert that something is correct. I want to make sure that I assert that the name starts with a capital letter. So is true, I'm going to say, okay, is valid, right? Is a valid name, string name. I'm going to say, okay, return name does not equal null, and name dot char at 0 is a character dot uppercase, right? Character dot is uppercase. Good. So is that valid? Is the name valid? Is valid r.getName. If that's valid, then great. Must be a capital letter. Okay? But if it's not, I want it to throw an exception. And if it throws an exception, I want it to roll back all of the writes that we have seen. So it should either write all of the data or none of the data, but it shouldn't just write one of the records. So let's rewrite this code. Let's reuse this code now down here in our little pipeline. I'm going to inject that here as well. So I'll say private final service. And basically, all of this goes away, doesn't it? So we can keep that. We say this dot service dot save all. Good. All right. There's our pipeline. Now, I want to make sure that, if we save everything, it either all gets saved or none of it. So we use the transactional operator here to delimit our transactions. We say private final transactional operator. And we say this dot transactional operator dot transactional. And we wrap that whole pipeline in the transaction demarcation, explicit demarcation. Okay? So this should work. Let's just run this code as we've written it. We should see that working just fine. Let's see what happens. Okay, that worked fine. Now let's change my name to lowercase. Okay. Run this again. You can see the log. There you go. That's fine. It's just a log. And good. So now we got nothing there. So remember what happened, right? Let's make this capital, and I'll go to the middle one here, lowercase d. Okay. Okay. So it doesn't matter where I do it, it rolls back the entire write, and that's okay. So I'm deleting everything that happens outside of the transaction, then I write the data to the database inside the transaction, and then I read all outside of the transaction. So this is atomic, but everything around it is not. You can wrap the whole thing inside of the transactional operator if you want, but either way, it's up to you. So now we have reactive transaction management, we have reactive SQL. Can I build an HTTP API, right? Well, of course, I can do that. I can say at rest controller, I can say reservation rest controller, and I can inject my reservation rest repository like that, and I can create a get endpoint reservations and publisher of reservation. I can do all this just like I would normally do. This dot reservation repository dot find all, and that would be fine. It's a very familiar style. I'm sure you've all seen this before. And I like the style. It's okay, but I actually really like the new functional reactive style. So instead of doing that, what I like to do is to go up to my beans and say bean router function server response routes return route dot build dot get reservations new handler function return server response dot okay dot body, and I'm going to inject my reservation repository. Okay. .findAll .class. Okay, so what do we got? Let's see. There's my functional reactive endpoint, right? It's much cleaner. It's just a one-liner for one HTTP endpoint. Restart that. Okay, there's my data. So now I have a functional reactive HTTP endpoint. I've got data in the database, and I'm sure you're thinking, who cares? Like, it's 8 records, right? All I did was write 8 records to the database. I did it with SQL, and I did it with JSON. You could have done that yesterday, right? You don't need me for that. You could have done that with servlets and JDBC. Where does this really help me? What's reactive about this? Well, let's talk about that. Reactive comes into its own. It's most valuable when you're using it to store data or to work with data that is potentially long-lived. Wherever you might keep a thread open, reactive programming can be very useful because it can help you free up that thread. Where do you keep threads open? Well, anything that requires a constant connection because you want liveliness of the data. You want to be constantly connected so you get immediate updates. This is a good candidate for reactive programming. So anything that supports that kind of interaction model, Websockets, server-send events, all these kinds of things, good candidates for this. What kind of use cases can you imagine that require this? Well, chat, right? Status, notifications, telepresence, right? Stock tickers, these kinds of things. Updates that are being fed to you live also are good candidates for this kind of thing. So let's now reimagine our example here. Let's introduce a new dimension. What I'm going to do is I'm going to create a greetings service. Okay? And this service is going to produce a series of greetings responses when you send a greetings request. Okay? And this is just a regular service, and it's going to have a DTO of type greetings response. Okay? Private string, message. Okay? At data. Okay, there's this. And we're going to have a greetings response, or a greetings request, I mean. So class, private string name. There we are. And that's the basic structure. You're going to have, when somebody sends me one request with a name, I'm going to send back an infinite stream of greetings. So let's do that. We're going to say flux.fromStream, stream.generate, passing in a new supplier, new greetings response. Hello, request.getName at instant.now, okay? So I'm just returning an infinite stream of values. The thing is, I want to also delay each response, okay? I'm going to delay by 1 second. So it's going to produce a new response every second. That way it's not going to go so fast that we can't see it. So I'm creating a reactive stream, but I'm introducing time. And the reason I can do this is because behind the scenes, Reactor is powered by a scheduler. You don't need to worry about the scheduler most of the time. The scheduler is the thing that moves work from one thread to another. You don't have to care about it. It just works. But it's always there. It's the thing that allows us to do the work that we're doing. It's the thing that moves work from one CPU to another very efficiently. The trick, of course, is to never block the thread. Never do work on the scheduler, on the threads that the scheduler gives you that blocks that thread. So I could change the scheduler. I could say, hey, I want to subscribe on this scheduler from this thread pool, right? A scheduler is a thing that does the actual mapping to threads, right? So I could provide my own thread pool, but that's usually a code smell because it means that you're doing something that requires more threads in order to scale out. Remember, we have one thread by default per core. This is each thread is an event loop. So as long as you're using asynchronous I/O and non-blocking technology like reactive programming, you're not going to block those threads. But it's very important that you know that if you do block those threads, you're not just stopping one user, you're stopping a huge number of your users. So if you have 4 threads on the entire system, and all of them are event loops, blocking one thread doesn't mean blocking one user, it means blocking 25% of your users, right? It's very important. So you can use a nice tool that we have called block count. This is a tool that we wrote that you can download. You can use it in your Maven projects. You just add it to the class path, and then you do block count.install. And as soon as you do something silly like thread.sleep on a non-blocking thread, it'll throw an exception. Okay, it's a Java agent. You add it to the class path, and it detects this stuff for you. Very, very powerful tool to help you find where you're blocking when you shouldn't be blocking. that scheduler is also what allows us to do things like sleeping here. So now I've got the service. What I want to do is I want to create a thing that I can use to see that never-ending stream of data. So I'm going to create a WebSocket endpoint here. Greeting WebSocket configuration at bean. And it's going to be a WebSocket handler. And this is going to be where our business logic is. We're going to come back to this in a second, okay? But to do, all right? It's a configuration class. And in order to do its work, we're going to need a simple URL handler mapping. Return new simple URL handler mapping. It's going to have two things. It's going to have the HTTP endpoint upgrade URL. That's going to map to a WebSocket handler like this, WSH. Okay? And it's going to have a priority. So there we go. So that's this. And the only thing we need left is a WebSocket handler adapter. Okay? Now, let's implement our WebSocket handler. This is where the business logic is. In order to do this, we're going to use this new greeting service that we just created. Greeting service. We're going to say new WebSocket handler. And when the client first connects, we're going to establish a WebSocket session. When the WebSocket session is created, I'm going to read the data. I'll say session.receive. I'm going to take the data that comes in from the WebSocket message, and I'm going to get the text. So what's going to happen is our WebSocket client is going to send a name, just a single name, John or Jane or whatever. We're going to take that name and turn it into text. We're going to take each name and turn it into a new greetings request, passing in that like this. We're going to take each one of those and call our greetings service, which we've injected there, .greet, right? There's that. And then for each one of those, we're going to take the greetings response and get the message, okay? And then for each one of those, we're going to turn it into a text message, a WebSocket text message. So session.textMessage, text. Okay. Map. There you go. So that's the entire interaction, if you will. That's the entire chat. And I can just send it like this. I can say session.send map. That's my entire WebSocket application. Obviously, you could clean this up very nicely, like so. Now, the problem is that in order to demonstrate this code, I need to do something that I would not do if I could find a better, faster, more elegant way to do it. But it's the fastest way I know how to do this, and it's something that I wouldn't do in front of you, my dear audience. You are all polite, kind people. And so if I could think of something more appropriate to demonstrate this, I would. But I can't. Okay? So I'm kind of stuck. I need to do something that I don't like doing in public. I don't like doing it at all, really. I need to write JavaScript. So, file, ws.html, HTML, body, script, window.add event listener, load, function e, var ws, localhost, 8080/ws greetings, ws.add event listener open. When the socket first connects, we're going to send data into the socket. So we're going to say ws.send Devoxx UA. Okay. And we're going to say when the data comes back, when we get new messages, we're going to log those messages out. So here's a go. Message. Okay. Console.log new message, message.data. Okay, let's try this. Okay, localhost, ws.html, and browser. Okay, there you go. Every second, forever and ever and ever, it's going to produce a new value. It's going to keep going forever and ever and ever. It has no end. It is endless. It is infinite. It goes on and on and on and on. Forever and ever and ever and ever. It's like the oceans and the stars and the bugs in your code. Infinite, my friends. So we've got this infinite stream, and that's okay. You can see that as we move forward in time, it's going to pump a new message every second. But in between those new messages, in between the raindrops, that thread is free. Somebody else on the system can reuse it to do other work. We're not blocking that thread. This is the true power of reactive programming. It allows us to handle more requests at the same time. It's not about making one transaction faster. It's about allowing us to handle many more transactions. It's about scalability. To use simple math, you can do the same number of requests with half of the hardware. Or you can handle double the number of requests with the same hardware. It's about making your data center bill more friendly, more fun. So we've got now a WebSocket service. We've got an HTTP API. And I like both of those things. But I don't really think they're a great choice for microservices, right? There's some problems with HTTP. First of all, HTTP 2 is pipelined, but it's not multiplexed, right? WebSockets, they don't have headers. How are you supposed to do security? How are you supposed to propagate out-of-band information like a token if you have no headers for security, right? These protocols are, they require you to make a request and get a response. They can't keep a connection open. This is very inefficient. Constant network ACK makes it very slow to communicate with one other service. So there's some fundamental limitations in HTTP. It's very scalable. It's a great document retrieval protocol, but it's not a great distributed systems protocol. It's not a great microservice protocol. So in Spring, we've become big fans of something called RSocket. RSocket is a protocol that was originally developed by Facebook. How many of you have heard of Facebook? I don't use it, but apparently people do. Who knew? Facebook built, actually engineers from Netflix went to Facebook, and these engineers worked on this protocol called RSocket. RSocket is a binary protocol. It's multiplexed, so you can have multiple transactions in the same connection. It's stateful, so you connect and you stay connected for the entire lifetime of your application. So you're not constantly hacking and disconnecting and doing all this stuff again. It's bi-directional, so there's no such thing as client-server. It's requester, responder, right? But both sides can be a requester or a responder. And it supports all the different message exchange patterns. I can send a request with one value or a stream of values. I can get no value back. I can send in a stream of values in. I can do fire and forget. I can do streams of values, bi-directionally. So I can do all sorts of very interesting things. And it's being used by some very interesting companies. We just mentioned Facebook. When Facebook developed this technology, they built a number of different clients that you can use to talk to this protocol. These clients support, for example, JavaScript. There's Java support. And the Java implementation is based on Reactor, right? So it's, as you can imagine, very easy to integrate into a Spring application. So that's what I'm going to do. I'm going to use the new Spring support for RSocket to turn this service into an RSocket service. My greeting service will be an RSocket service. All I need to do is find the thing. Here we are, at controller, at message mapping. Okay, greetings. There we are. There's my RSocket controller. I'm going to now start this up on a different port. So I'm going to start that up. There's my entire RSocket service. It's already done. Now I need to build a client. I'll use Kotlin. Why not? Client. Okay. And we're going to use the reactive web support. RSocket. Okay. Hit generate. Good stuff. So now, here's my Kotlin application. And you can use the DSL. How many of you know about the functional reactive DSL for Kotlin? So I'm going to define a bean of type, I'm going to say I want to inject the RSocket requester .builder. I'm going to connect statically to localhost 7777. I'm going to block. Okay, there's this. That's going to create one bean. Hello? Val RSocket. That's fine. Okay, whatever. So moving on. So we've got that. And what I want to do now is I want to build an application, an event listener. It's just going to listen for an event. And when the application ready event is emitted, it's going to inject the RSocket client. RSocket client equals ref RSocket requestor. So the type of this thing here, RSocket requestor, is what I want to inject here. Okay? So there's that. So I'm injecting it here, and I can just use that. I can say RSocket requestor dot route greetings. Come on. When I get to the data, I want to send in a request. Now I need to do something terrible, something that you should never ever do, ever, not even when you're all by yourself at home and no one is looking. I want to say return RSocket. Actually, that should work. There you go. That works. Okay. What I want to do is I'm going to do something terrible, something that you should never ever do, ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So here's this DTO, my greetings request and my greetings response. The problem with this, of course, is that the greetings request and the greetings response are Java, and they're needed over here in Kotlin. So IntelliJ has a pretty tricky, pretty sneaky little trick. Did you see this? What's that about? Now, notice that there's no way to do this the other way. It's a one direction. So here we go. Ugh, actually, that's way worse. So I don't actually use that. What you can do is you say data class greetings request val name string good and data class greetings response val message. Okay. Good. So there's my two types, my two DTOs. And what I'm going to say is I'm going to say, okay, when I send a request in Devoxx UA, I expect to get a stream of values back, retrieve a publisher of greetings response, and subscribe. Print line, new message. Okay. So this is going to be an RSocket client that will connect. Oops, I might have the wrong port. Server port equals 8000. Yeah. So this is going to be an RSocket client, and it's going to connect over the network and make a RSocket call to the greetings service on the producer side. That's a natively reactive binary network protocol. It can do back pressure. HTTP doesn't do back pressure. You can cancel just once, but you can't resume, right? It's not connected forever. This will actually, I can stop, I can pause, I can do resumption, I can do all sorts of very interesting things here with RSocket that just wouldn't be possible with regular HTTP. Now, I mentioned some small companies that are already using this to great effect. Obviously, we talked about Netflix and Facebook. There's a small company in China called Alibaba. They're all Spring. Everything in Alibaba is Spring. At their scale, did you hear about the 11/11 last year or this year? Last year, 2018. On November 11th, they sold $30 billion in 24 hours. Did you sell $30 billion in 24 hours last year? Just wondering. No? Okay. Well, then that's pretty awesome. $30 billion US in 24 hours. And all of that was powered by Spring. But as you can imagine, they're very keen on reactive programming. They want to scale to greater heights. And so when I talk to them, I spend a lot of time in China talking to these large organizations. I talk to them about RSocket and reactive programming. They're very interested in that. So Pivotal and Netify and Alibaba and a bunch of other partners, we just announced the Reactive Foundation. And RSocket is one of the technologies that's involved in that. I think it's got a good future, and it's natively integrated into Spring Boot 2.2, which is GA, and Spring Framework 5.2, which is also GA. One of the interesting things that we didn't get to talk about today is Spring Cloud Gateway, which is a micro proxy. It's a gateway, API gateway, and it can do HTTP and RSocket proxying. There's lots of interesting opportunities, my friends. All right, so first of all, who had fun? Who learned something new? Good stuff, right on. I am so grateful for the opportunity to be here. I hope you had fun. I certainly had fun. Obviously, I'm wearing the Spring t-shirt and the Spring underwear. Of course I had fun. I always had fun. I'm a very happy guy. I am so grateful for you all. Thanks for coming out. I really, really appreciate it. Спасибо, dziękuję. Thank you so much.